In this video, we are going to be looking at the average value over an interval. So the average value in calculus allows us to find the average value of a continuous variable, which is different than a discrete variable. So when you have a discrete variable, like the number of household pets, for example, you can find the average by adding up the number of pets in each household and then dividing that by the number of households, right? But with a continuous variable, like temperature in a day, for example, there are too many possible temperatures to add up. That is why we use a definite integral. Down here, we have a picture of that very situation. So here are the temperatures in a 24-hour period from midnight to midnight here. This is, we'll call this A, and we'll call this B. But this is from midnight to midnight, and it gets colder and then it gets warmer. But the variable is continuous, so you can't add up all the temperatures, because if you took a temperature, say at 6 a.m., you'd be at around 58 degrees. But then would you go to 6:01 a.m., 6:02 a.m., 6:02 a.m. and 30 seconds, 6:02 a.m. and 32 seconds? It's a continuous variable. So it's impossible to add up all the numbers. So the way we do it is we find the area underneath the curve from A to B, which is denoted by this part of the calculation. And then we divide by the width of the interval. If I take B minus A here, the width of the interval is 24. And that's what you get if you would take B minus A, if you were doing it in military time anyway. And so that'll give you the average value. So this graph again shows the temperatures in a typical day from midnight to midnight, with the line representing the average value of those temperatures. So geometrically, the average value, or the average temperature here represented by the horizontal line, will create a rectangle whose area is the same as the area under the curve from midnight to midnight. So this rectangle with a temperature of about 69.3 degrees will have the same area underneath the rectangle as you would underneath the curve from midnight to midnight from A to B. So that's the way we find this, is we take the integral and then we divide by the width of the interval. That's what this formula is. So it's 1 over B minus A times the integral from A to B of the function. Let's give it a try here in example 8. Here it says, find the average value of a function, f of x equals x minus 3x squared over the interval from -1 to 2. So if we use our formula for average value, it's 1 over b minus a times the integral from a to b of the function, like that. So for our cases, a is a -1 and b is 2. So we're going to have 1 over 2 minus a -1 from our formula. And we'll integrate from a -1 to 2 of our function here, which is x minus 3x squared dx. Give that a try, and we'll compare our answers. Pause the video and show your work. So integrating this, the 1 over 2 minus a -2 becomes 1/3, because you'd add the 1 from -1 to 2. X will become x squared over 2. 3x squared, when you integrate it, will become 3x cubed over 3. Could cancel those out right away. And then we substitute in our 2, and we substitute in our -1 from below. In our first parentheses, we'll get a -6. In our second parentheses, we'll get a +3/2. Combining these two, we get an average value of a -2.5. All right, I hope that all makes sense. Thanks for watching.